All right. Once again, problem number 4. We have a ball that's fired and it lands at the same height that it's fired at. So we can actually go ahead and use our range formula. So our range is 50 meters. So I'm going to use range equals v naught squared sine of 2 theta divided by g. For range, I'll use 50. For v naught, I'll put 24. Of course, I'll have to square it. For g, I'm going to end up putting 9.81. And I'm going to go ahead and solve for the range. Wow. Now this question number 5, this is exactly related to the problem that you did in class where we have an 80-meter high cliff, so y naught is 80. And then y is going to be 0. We have x naught is 0 because it's always 0. And then x equals 160. You've actually done this problem in class. At least you've done part A in class. Where you actually, again, you solve for the time and then you use that to get v naught x. But part B is a little bit different. And what I want to say is for part B, you're going to have v naught x from A. And then you need to actually get vy by any means that you want. You can have it fall from rest in the y direction 80 meters. Or you can use, basically there's a lot of different ways to get this speed. So you need to solve for it. And what I wanted to say is in order to get the speed, for now, what we mean by the speed is we want v naught x and v naught y. We want both the velocities. But I did want to go on and talk about the fact that as we go here, to get the total speed, we're going to actually need to use the distance formula, Pythagoras' theorem, because what we're saying is that there's a v naught x and there's a v naught y, and the speed forms a triangle, and the hypotenuse of this triangle is the speed. If that's all too much for you, just use this formula to go ahead and get the speed. And that's it for our problems. And hopefully these are a helpful set of hints.